This is a program demonstration of SN Design, a soil nail wall design package. The first tab is the Project Manager, which displays project data and allows projects to be created, opened, moved, deleted, or searched. The next tab is for material data, to enter material properties for each ground layer. Next is the Surface tab. The surface may be defined by entering points with the mouse or copying and pasting survey points from Excel. The LiDAR tab allows LiDAR data to be imported, transformed, compressed, and edited. The Partitions tab allows specification of a line or curve cross-section on the slope, which can define points for the existing slope in the SN Design tab. The SN Design tab contains everything required to analyze or design a 2D cross-section of a soil nail wall. The Geometries tab specifies the geometry of the existing slope, the wall, the downslope, and the back slope. The geometry may be input in XY coordinates or angle length coordinates. Purple cells in the grid indicate that ranges may be entered for design purposes. In this case, the wall height is required to be between 30 and 35 feet, and the wall batter angle may be between 3 and 20 degrees. The program will determine the optimum values. Likewise, the downslope and back slope may be specified. The back slope allows surcharge loads to be specified for each segment. Different surcharge loads may be specified for staging cuts. The Soil Layers tab specifies the point locations of each soil layer. The Groundwater tab specifies the location of the water table. Points may be entered, moved, or deleted at the click of a mouse. The Nails tab allows entry of either uniform or non-uniform nail properties. In this case, we will use uniform nails. A nail length range of 30 to 60 feet and a nail inclination angle of 0 to 30 degrees are entered for design. The program will determine the best values. The Seismic Coefficients tab allows seismic loading to be included or excluded. We'll exclude it for now. The Wall Facing tab allows design of several wall facing parameters. Shown as purple cells. Design checks are shown as icons in corresponding cells. The result of the design check is shown in the status bar at the bottom when the mouse is moved over the cell. Additional design checks are shown in the next tab. The External Stability tab shows all intermediate variables used in the calculations, with checks on eccentricity, factors of safety for sliding, overturning, and bearing capacity. The Global Stability tab allows results from the modified Bishop's method to be computed. A traditional brute force search is supported, which calculates safety factors for the 10 failure circles with the lowest factors of safety. The Slices tab shows detailed information about each slice used in the calculation. The Radius Control tab allows restrictions on the search parameters. In this case, we do not search for failure circles, which intersect the slope between the top of the wall and the beginning of the surcharge load. The Min Failure Circle tab shows a calculation of a multidimensional global minimization search that locates the failure circle with the lowest factor of safety in far less time than traditional brute force technique. The Design tab designs a soil nail wall within the specified design parameter ranges at a required factor of safety, minimizing the cost. The material and labor costs must be entered for steel, concrete, wall facing, nail installation, drilling, staging cuts, as well as the minimum required factor of safety. In this case, the design required a search time of 2 minutes and 17 seconds. The Parameter Analysis tab shows the results of the design search. Clicking the Best button shows the best input design parameters with resulting cost and factor of safety. By moving the scroll bar of an input, such as the wall height, the resulting change in cost and factor of safety is shown in the output scroll bars. Notice how the factor of safety changes when the wall height increases. This change can be shown graphically in 2D by selecting the wall height input checkbox and the factor of safety output checkbox. Notice how the factor of safety changes as the wall batter angle is changed. This change can be shown graphically in 2D by selecting the wall height input checkbox and the factor of safety output checkbox. Notice how the factor of safety changes as the wall batter angle is changed. And now, see how they change as the nail length is changed. The relationship between nail length and nail inclination angle can also be observed. In this case, the nail inclination angle should decrease when the nail length increases, up to a length of 48 feet, beyond which the nail inclination angle and the nail length have no critical effect on the factor of safety. An additional SN Design tab was created automatically by the design search, containing the optimal design parameters. After reviewing the design, a full report can be generated, showing all the input data, staging cuts, factors of safety, and a glossary of terms. This demonstrates how SN Design will revolutionize engineering by making a single engineer hundreds of times more productive, with the ability to produce more cost-effective designs, and with parameter analysis tools, giving the engineer a more in-depth understanding of design parameters.